Hey everyone, David Shapiro here. The reason that we're here recording this video again is because I'm kind of an idiot. Actually, no, I take that back. I just really strongly adhere to the agile methodology, and really I invented the agile methodology as a small child because I would just improvise until I got stuck, and then I would do it again and learn. So really agile is just like the natural way of doing things. That's my excuse, and I'm sticking to it. So, without further ado, I have revisited the process of parsing Wikipedia. So here's what I'm doing. I've changed my methodology. So now I'm saving every individual article as a JSON file, and this is what it looks like. So ID, so that's the article ID that you see. Here, let me zoom in a little bit. There, now you can probably see better. So you got the article ID, 1575, and then here's the actual text, and you see this is lovely plain text. It's easy to read. There's no links or anything. So this plain text version can be easily used for anything, whether you want to just print it out or you want to index it in Solr, which is what I want to do because of my AGI research. I need an offline encyclopedia. So everyone is in this nice little JSON file. This is high fidelity. I've preserved pretty much all information. And let me show you how I've done this. So let me go ahead and also open the wiki to text. So right here I've just got a simple supervisor function that kicks off, or supervisor script that kicks off the main function. As I've shown in past videos, I've got it all as the stream. I can also just show you what this looks like. So if you go download Wikipedia, it'll look like this. The file name is a little bit longer. I shortened it up just so that you see that it's the English Wikipedia of the year 2021 of April 1st. So this is a month and a half old. That's okay. You see it's an 80 gigabyte file though. So because it's a monolithic file, you need to read it one line at a time. It's just too much data to process all at once. So that leads to everything else that you see here. So here's the new function that I wrote. It's based on the old function. What I do is I pass it the name of this massive XML file, and then I give it a document to save the subfiles to. And then it's just a real simple process that iterates through this first file line by line. It looks for the XML tag page, and then it looks for the XML tag end of page. And if it's between that, it just adds to the line. And then I've got all this commented out. This is how I used to do it, and it was slower. And this is how I do it now. Process save article. So what I do there is I just save the article. I do the analysis to get the document ID, title, and text. And then I change this, analyze chunk. I change this as well. So what this does now is, one of the things that it does is it calls the dwiki function. And the dwiki function, going up a little further, I did all this stuff by hand. And this is why I say I'm an idiot. I did all this stuff by hand because initially I found the wiki text parser, which is let me show you at the top. So you can just do a pip install wiki text parser. It is exactly what it says on the tin. It just parses wiki text to plain text or whatever else you want. So yeah, so WTP, it does everything I wanted it to. The reason I didn't do it is because regex was faster, but that's where I'm an idiot. Because I have done so much parallel processing in the past. I don't know why it took me so long to figure this out. So what I did to make it just as fast, to use this really robust function. So I just pass in the wiki text and it spits out a plain text version. It was really slow. If you do just this, it takes about like 5 or 6 seconds. It's 2 to 6 seconds per article, which is really slow when you've got 6 million articles, right? Well, okay, sure. But Python has this handy-dandy built-in stuff where you can just call thread. And so what thread does is I just pass it off and I say, hey, go do this and then don't give me any results. I don't care. Because you see this, the process and save article, it doesn't have any return. So it goes off into oblivion and does its own thing. So there you have it. Here's another example. This is the entry for ASCII. So you can see you jump right in. This is completely legible. You could use this as is. Here's another one, August William Derleth. Again, perfectly legible, no HTML, no XML, no Markdown, nothing. Let me go back to this. Let's see if I can zoom in. There we go. So you can see these articles going by. It processes a few dozen articles per second. Overall, I estimate it does about 1,500 articles a minute on average. So if it does 1,500 articles a minute on average, so that's 1,500, zoom in a little bit more. Wikipedia, once you remove all of the redirects and disambiguation pages, is about 5 million articles. So you divide that out and you say, okay, 1,500 articles per minute divided by, or 5 million articles divided by 15 per minute. That's 3,300 minutes, which is about 55 hours to fully index Wikipedia. And then it dumps it into a nice, easily reusable folder, which I've got, named Wiki Plaintext. And the file name is the same as the article ID. I figured I don't need to generate anything fancy. I just give it the article ID, and away it goes. And you see each article, they vary in size. Let's see, at the top, we've got the largest one is 1/4 of a megabyte, so that's not too big. In recreational mathematics, of course, a math article is the largest one. So, here's a good example of something that it didn't quite get out, where it looks like it didn't get a table. So I might have to go back and remove some of the table data, but really, because I'm going to have this read by GPT-3 or similar, what do you call it, deep learning models, I'm actually not so concerned about removing everything as long as it's mostly legible. Because the thing is, for these massive, what do you call it, models, they understand when they're reading code versus when they're not. So I might not worry about removing the tables, especially because sometimes you get really useful information preserved in the tables. It might be better just to remove all the style. We'll see. I'll do some experimentation. So this is a fine example of when it doesn't quite work, but you still see there's a tremendous amount of usable information in this. Let's see. There was some